Everyone. Good evening, everyone. And specifically, Ravi sir, I am the core presenter of this particular topic, okay, which states multi-document text summarization using digital transform. And coming to the background, like I'm currently working for Accenture and I'm working as a data science and machine learning manager over there. So my role over there is to architect and deliver solutions to improvise business outcomes. So this is one of the research I would say, but we came up with this particular paper when we were solutioning something for one of our clients, okay, in a sector of insurance domain. But the paper, the data set, and whatever research that we did was not with respect to any client data. We just got some data from internet and we did our research. Okay, so I'm just proceeding ahead with the introduction part. So the topic overall gives a very quite like explanation about the whole research. It is about text summarization. So we all are aware that there is a huge amount of text data which is available. When it comes to any structured data which is available in form of tables and all, deriving insight become very simpler. There are so many amount of data analysis packages, libraries which you can use, and you can analyze your data, the distribution of your data, and whatever it is. But when it comes to unstructured data, which are normally stored in form of PDFs, Excels, text files, and all, which is normally also difficult for a normal human being to read and understand everything from scratch. Okay, we normally get bored when we see huge amount of data, and if someone asks me, okay, get me some important information out of this. So text summarization is one of the important concept, okay, wherein we try to get some insight, some precise summary from the huge documents. Okay, and no matter like the approach that we have developed, it helps you to get this text summarization from any format of documents, may it be PDF documents, whatever it is, we can do that. Okay, and our idea is not to demonstrate text summarization, but is to understand that how transformers, which are the advanced deep learning algorithm, the transfer learning based approaches which are developed by training on huge amount of data, how it can help us to solve the problems. Okay, and hence what the topic says is multi-document text summarization using distilled transformers. So what is this distilled transformers and how are they different from the normal transformers? So distillation is normally a process where you do some sort of modification to your base version. Okay, you do some kind of, this is a term which comes from chemistry. We do some distillation on some of our formulas. Okay, and then we get something new. So the same approach came up with the transformers part. So with distillation, we are doing some small modifications to our base versions of transformers. Okay, and hence we are checking if the performance is getting improved. Okay, and when we speak about the performance, it is not just about how well the transformer is working and how best the summary has been given. Okay, there are some additional metrics that our research also looks into. So coming to the shortcomings, okay, shortcomings of the existing approach. When I say about the existing approach, the existing transformers. So existing transformers are like BART, Pegasus, okay. So these are some of the transformers which are highly utilized for text summarization when it comes to abstractive text summarization. And the problems which are associated with those models are very heavy. Those are very bulky. Even if you try to download those models in your local system, you need a space of 2.3 GB, 3 GB and all. Okay. And also the inference time. The larger the model, the bulky the model, what it directly says is the number of parameters which are present for training and inferences are also very high. So if the number of parameter increases, the inference time taken for any new text data will also increase. Okay, so these are the core shortcomings on which we try to work on, like how we can use distilled transformers and how we can deliver better performance along with restricted size of the models. And the problem that we saw is like whenever we used to showcase this particular approach to our clients, we understood that the storage space, whatever the client has, is limited. No one can spend around 2 to 3 GB of data of storage size just for one model. And if you keep on hyperparameter tuning the model, you keep on modifying and upgrading the model, the versions will keep on building up. So we always want something which is lightweight, which can be used in a very simpler manner. Okay. So for that purpose, we went ahead with this approach. Okay. So this basically speaks about text summarization model. If you look, the proposed approach is almost similar to any text summarization architecture that we might have seen before. What is different in our approach is we are also accepting different types of documents, as I clearly stated in the beginning. And this is a multi-document text summarization. So we welcome PDF documents, documents which are common in docs format, whatever it is. We pass it to the text processing pipeline. So when we speak in terms of NLP, and when we say there is some text pre-processing or extraction that we do, so we normally understand that we need some sort of text pre-processing because there are a lot of redundant or garbage data, I would say, which is not much intuitive, or it is not providing any more information to our model, but still we have it. So in that case, we pass it to the text pre-processing where we do some kind of basic cleansing. We are not doing any kind of very major cleansing or using any kind of algorithmic techniques for doing that. We just do some sort of cleansing like punctuations, removal of punctuations or special characters or numbers, whatever are not required. Okay, depending upon the scenario. Again, as I said, the scenario to scenario, the text pre-processing techniques will change. In some sectors, you would need the numbers because that makes a huge difference, but in some you won't. So it depends upon the sectors and the data sets that you are working on. Then comes the text summarization model. Okay, so as you can see, there are two text summarization models that we have over here. One is the DISTILLED BART and one is the DISTILLED Pegasus. So these are the modified version of the base transformers, BART and Pegasus. And the way it is modified internally is an architectural change which has been made. Okay, and all those transformers are readily available on the Hugging Face. So everything, whatever we are using, we are directly using from a known repository, that is the Hugging Face repository, where you see all those valid and utilized transformers. Okay, and last is the summary evaluation model. So like going inside the details, whatever I explained, the same things are mentioned on this particular screen, starting with the text pre-processing related to the data cleaning. The text summarization model uses the DISTILLED BART and DISTILLED Pegasus, which are the distilled version of the pre-existing BART and Pegasus transformers. Okay, and then we have a model evaluation component, which is ideally utilized for understanding how well the summarization has happened. Okay, and when we speak about abstract to summarization, there is one of the very important metric that we have understood while our research is the route score. Okay, so route score is very much similar to recall. So in case of recall, it basically determines that out of all the actual incidents, how many are correctly predicted. The same thing happens in case of routes. So out of all the actual words which are occurring in your actual input data, how many are captured and how many are intuitively showcased within your summary. So that is how your route score will be. Okay, route score normally goes high for for extract to summarization, where there is word to word summary that we do. For abstract to summarization, we generally infer out something. So route score is always limited to a certain range. We may or may not get a very high route score like 90% and all. It might get limited to some extent. So what are the benefits that we observe from this approach? Okay, as I said, that the main concern and the main problem that our clients are facing is the inference time and the size of the model. With this approach, we were able to deliver them comparatively similar performance. Okay, with higher inference time, like if you see the experimental results, whatever we can see below. Okay, it says that DISTILLED BART was one of the best transformer that we saw with respect to our metrics, wherein the size of the transformer was only 1.4 GB as compared to 3 GB and 2.5 GB of the actual versions of those transformers. And the inference time was only 31 seconds. Okay, as compared to 83 seconds or 100 seconds, whatever we saw with the earlier versions of the transformer. So, and also the document, the approach, whatever we have defined, it accepts all sorts of documents like PDF documents or docs, whatever kind of formats are available. And these are the experimental results, just like whatever I've showcased in Word format over here. You can see the same in a representable format. So we can see that if we compare DISTILLED BART and DISTILLED Pegasus model, which were the two models under study, you can see that the route score of DISTILLED BART is 39%, which is comparatively very higher as compared to DISTILLED Pegasus. Okay. Now, what is this routes 1, routes 2? So we can have very different versions of routes. when we say that, okay, calculate route score with unigram, that is only consider one word at a time, then that is route 1. When we say that, okay, use bigram format for calculating the performance metric, then we go for route 2. Okay, the same has been showcased with respect to the bar graph, where we can clearly see that distal bar outperforms distal Pegasus. The reason that we are not showing this route score for Pegasus and bar is we are aware that those distal models are just some upgradation and modification done to their parent versions. Okay, so our idea here was not specifically to check the performance, that how the route score is better and which is performing better, but we wanted to understand the inference time, the size, and how it is deployable. Will the customer accept this particular model if we showcase them? So that was the main purpose of the whole research. And then if we speak about the conclusions, so we understood that distill models are always robust and pertinent. And if we compare the performance of the distill models, they are very much comparable to their parent versions. They provide good, better summarizations of very large data as well. Okay, and the whole approach accept any sort of documents, the PDF and doc formats. And what are the like we are not stopping here. We basically want to progress ahead. We want to fine tune our model, because in the first research, our objective was not on performance, but on the making it more modular for deployment. So the size and the inference time is comparatively good, but now we want to fine tune that for the overall performance. And we want to check that how can we deploy that? Is it like can we deploy that and make it available for mobile usage as well? Okay, so those are some of the ideas that we are planning to go ahead with. Also, the current approach only accepts PDFs and doc format, but we are also looking for images. So like using some OCR technique, we will be reading the text within the images, and then we will be passing to the test this model, whatever we are developing. So Ravi sir, this is all about the research that we have done. Are there any questions for me?
For your presentation. Yeah, it's a good presentation. Just a casual thing is like uh, we appreciate being in industry, like presenting white papers is really nice.
Thank you, sir.
Yeah, that's one thing, because industrialists, we don't see them coming to any conferences, very less presenting
Yeah,
any papers. So like
I understand, sir.
how like we have second person like you and one more person before, we're also from
Yeah, there are
if
three groups from Accenture that we have presented actually.
oh, wonderful.
Yeah.
That's great. Nice to know that. Like, uh, is it is it in from R&D team, or is it like from different?
Sir, so basically we are not from any R&D teams. What happens is like we have certain RFPs where we work for proposals for different clients, and we develop some internal products. Like this is one of the internal product that we have developed. And when we basically start proposing those models to the clients, we understand that, okay, this is not something that they can implement, because whatever of research that we do, it is not always going to be acceptable by the market standards. So something is only for study, something is for implementation. But when we go for implementation, we understand there are hiccups, like the cost, the implementation methodology, or maybe the expertise. People are not that expert to implement everything. So with this, our approach was not to basically lower the improve the performance, but to understand that how we can sell out our product, how we can make it compatible for people who are not able to afford very costly services. Like we basically deploy everything on clouds. So cloud, as you know, it just charges you for all your usage. So if we deploy this 3 GB of model on the cloud, and if there are like 100 requests, that would be around like $3,000 of costing per month. So we need to restrict all those things. So that is the reason that we are basically into this research of lowering the size and lowering the inference time.
Okay, that's wonderful. Good to see hear about this. Nice to see. Thank you.
Thanks a lot, sir. Thank you so much, sir.
Yeah.